The promise of the industrial Internet of Things is built on connectivity. We're told that by networking every asset to the cloud, we can use predictive maintenance to stop failures before they start and capture massive gains in factory efficiency. But on the actual factory floor, the environment is much more analog. You'll find heavy-duty presses and assembly lines designed for mechanical endurance, often operating in total isolation. These machines are robust, but they are also digital black boxes. They generate enormous amounts of operational force, but zero network-readable data. This creates a physical bottleneck. Until these machines can share their telemetry with modern servers, the potential for real-time optimization remains locked away inside the hardware. The problem is one of legacy. Most facilities are run by equipment designed decades ago, hardware that was never intended to join a modern network. When these machines do communicate, they use archaic industrial protocols like RS485 or Modbus. These are localized languages that the modern internet simply doesn't speak. Traditionally, the only way to modernize was a process called rip and replace, physically removing functional, multi-million-dollar machinery to make room for newer, natively connected versions. For most operators, this is a non-starter. The capital costs are immense, and the required facility downtime can halt production for weeks. This leaves managers in a bind. They are forced to choose between the reliability of their existing machines and the data insights they need to stay competitive. There is a way to bridge this gap without rebuilding the entire factory. It's a wrap and extend ecosystem called IIOTCore. This hardware gateway plugs directly into existing machinery. As shown on the left of this diagram, it intercepts fragmented data from legacy protocols like Modbus and Profibus. Inside the node, those inputs are instantly translated and merged into a cohesive data stream. It's then converted to high-speed packets sent at weights exceeding 12,000 packets per second, as seen in this throughput metric. By acting as a translation bridge, the hardware turns 30-year-old mechanical assets into cloud-ready nodes without requiring a single machine to be replaced. For a large-scale manufacturing operation, connectivity has to be more than just functional. It has to be fast enough to handle massive network loads without a single drop in performance whatsoever. To verify the system's reliability, the IIOTCore architecture was put through an intensive network stress test. The results demonstrated a single central node successfully managing 10,000 concurrent devices at once. Even at this extreme scale, the system maintained sub-millisecond data latency, ensuring the dashboard reflects a true, real-time view of the factory floor. These metrics show that IIOTCore provides the high-capacity, low-latency architecture required to serve as a primary data highway for large-scale enterprise facilities. Moving factory data to a global cloud introduces a hidden risk. Exposing proprietary operational telemetry to third-party jurisdictions can compromise sensitive trade secrets. To mitigate this, the IIOTCore ecosystem is built on a sovereign-by-design architecture. This ensures the facility maintains both physical and legal ownership of its data. By utilizing private cloud routing, sensitive machine data stays within your localized jurisdiction. It never has to leave your control to provide value. That security starts at the source. The hardware is manufactured in India, providing a secure, localized origin for critical industrial infrastructure. This allows facilities to gain the analytical power of the cloud while keeping their data behind an ironclad perimeter of localized control. The path to modernization no longer requires destroying the factory floor. It starts by bridging the gap. System architects and facility managers can secure their place in this ecosystem by joining the official wish list. Developer editions are scheduled to ship in Q2 2026, followed by the first full production batches in Q3. The future of industrial data isn't about erasing the past. It's about building the right connection.